Inverse functions. We're used to having y equals something like 3x plus 2. Inverse functions are just the opposite of those. Actually, we've been dealing with those a lot. If you look at our functions, x squared, the inverse of that one is square root of x. How do we know? The way we represent the difference is whenever we have an inverse function, we put the power -1 to it. Y equals x cubed. The inverse function of that one is the cube root of x. Here are the steps to find the inverse. Switch x and y. Then solve for y. No, so here's my function. My inverse function of that would be I first switch x and y. Now I solve for y. And divide by 3. So my inverse function is equal to x minus 2 over 3. That's all there is to it. Just switch x and y and solve for y. To test if is truly an inverse of f of x or of y, to test if what your inverse is, if it's truly an inverse, we have to do both of these composite functions. And if it's truly an inverse, the answer should come out to be x. Let's see. Let's do y of inverse of y. Using these two equations, we have y equals 3x plus 2. The inverse was x minus 2 over 3. These are my functions. So if I was to do this, that first one says I take all of these and put it in place of x. 3 times x minus 2 over 3. 3x plus 2. 3x plus 2. The 3's cancel. X minus 2 plus 2. The 2's cancel. Check. So that's the first thing I check. The second one, I check the other direction. I take this equation and plug it into that. So I have 3x plus 2 minus 2 over 3. On the top, the 2 and minus 2 cancel. 3x over 3, the 3's cancel, equals x. So they're truly inverses of each other. So that's the test. What if I gave you points on a graph? If G is equal to these points, the set of these points, Find the set, the inverse set. How do you find it? What's the first step? Switch X and Y. That's the easiest way to say it. So it's 4, 2. Just switch X and Y. Then there you go. No, there is no solving. I gave you a set. There is no Y. In this case, I gave you points. This is, remember, a point is made up of an X and Y. I switch X and Y. That's all you have to do. If Y equals X squared minus 5X, find inverse of Y.
Y squared 5 Y.
It's just, first thing is just easy. It's switch X and Y. Anywhere you see an X, make a Y, and see a Y, making an X. Now, solve for Y.
Like when we took 0, we put in return 1. No, I mean,
You're saying it's a quadratic equation. It said, you mean set it equal to 0?
like right now, how I know we solve for Y, but how do we do that? Like just plus 5Y and just continue to do. You know what I mean? No, okay.
Now, I'm trying to see what you mean. You're saying just move the 5, you can't, because you have to solve for something, you have to have them all to one side.
So to solve Y, do I put plus 5Y?
Why would you do that? Then you'd have Y's on both sides. You can't do that. Well, what we can try, since it's a quadratic equation, we can move the X over there. It's a quadratic equation where A is 1, B is -5, and C is -1. We could try that, see what happens. So we could try, we're solving for Y. So negative of -5 plus or minus -5 squared, 4 times 1 times -1 over 2 times 1. 5 plus or minus 25 plus 4 over 2. Square root of 29 over 2. And that wouldn't work. So actually, all this is saying is find the equation for the relation of that. So the equation of the relation is this. We can't go any further. But is that really an inverse? Because remember, if we do the no, because we still haven't solved for Y. Basically, we're solving for Y.
Solve for Y. I mean, like after that step, we say there's no one step. So we just solve Y.
Well, because it's a quadratic equation, we can't separate them. By definition, whenever we have quadratic equations, they have to equal 0. So we put everything on one side. If you do that, that doesn't help us much. Can we solve for x? So we can't do the quadratic formula. So we have x equals y squared minus 5y. Can we solve for y? No. At this stage, we can't. Right. There's possibilities of no solutions. So there's no solution in that one. One-to-one functions. What that means, for every value of x, there is one and only one value of y. So if we drew a graph, this is not one-to-one because this x has more than one value to it. In other words, I have 2, 1, and 2, 3. They're both members on the graph. 4. In other words, if I give you a series of points, if I give you a series of points, and I ask you, is this one-to-one? Only thing you have to look at is look at the x values. If all the x's are the same, then it's one-to-one. I mean, if all the x's are different, if all x values are different, then it is one-to-one. That's how we use, that's,
Like the main thing where it goes to 2, it's not.
it's exactly what it is, yeah. So since we have two values of x that are the same, it's one-to-one only if the y values are the same. If the y values are different, then it's not one-to-one. So in other words, each point, each x can only have one y value pointing to it.
So to be one-to-one, x value be one.
Has to have one and only one unique y value.
So it's not that. So is it not one-to-one because we have 2?
This is not one-to-one because we have two x's. It's the same x value, we have two y values. In other words, it fails the vertical line test.
So if you have 2, 1, would be 4, 1, would be 1, 1.
Yeah, if this was a 4, then it'd be one-to-one. Then it would be a function. Functions have to be one-to-one. Example 3. Also, if I have a function and if f of a equals f of b, the only way this is true is if a equals b. That's what that's saying. So if it is 1-to-1, then it has an inverse. The reason our other one didn't work, the x equals y squared minus y, because that graph would have looked like that. So for every one x, I would have two values of y. That's why I didn't have an inverse. If it's 1-to-1, then it has an inverse. Conversely, if it has an inverse, then it must be 1-to-1. For example, f of x equals 2x minus 3. Prove that it's 1-to-1.
Well,
It's the 1:1. That means 1, 2, 1. If it's 1-to-1, then it has an inverse. So this is y
so we
equal,
just put Y,
right, and
switch
then we switch them. Then we add 3 to both sides. X plus 3 equals 2y. Divide by 2. Inverse function is x plus 3. Now we have to test it. You have to test it doing this, the composite functions. And they both have to come out to being x. If they don't become x, then they're not inverse functions. All right, so here's another one for you. Prove that this one, given the function g of x equals x squared, prove it is not 1-to-1. Tell me what we got.
equals Y squared.
So y equals x squared, switch x and y, square root both sides. So y inverse is plus or minus square root of x. And there you have a problem. Because it's not 1-to-1. This one has two solutions. One's got positive, one's negative. So it's not 1-to-1. So not 1-to-1 because of it has two solutions. The horizontal line test. If it's possible, like it says here, if it's possible to draw a horizontal line intersect the graph more than once, if any horizontal line through the graph of f of x crosses more than once, then it is not 1-to-1. If you draw a horizontal line and it crosses the graph more than once, it's not one-to-one. For example, these four. Is this one-to-one? Yes. Is this one? Draw a horizontal line. Does it cross it more than once horizontally? So it's not one-to-one. This one? Yes. No. So that's easy as it gets. Now, whenever you graph one-to-one functions, to graph one-to-one functions, no, this is to graph it. The other one is just to determine if it's one-to-one. This is to graph it. So if I give you a function f of x, it's made up of all these points, x1, y1, x2, y2, x3, y3. To graph the inverse, just switch the x and y's. That's all it does. Pretty much what that does, if you look at a diagonal line, this graph of this function, the inverse of it looks like this. It's symmetric about the line y equals x. So if at 1, 3, it now becomes 3, 1. Yeah, just draw the original graph, fold the paper diagonally, and just trace it. Or just switch x and y values. Example 8. G of x equals x cubed plus 2. A. Is it 1-to-1? If so, what is the inverse function? Graph it. Is it 1-to-1? First, that's the easiest way to determine if it's 1-to-1. Does it have an inverse? X cubed plus 2. Switch x and y and solve for y. X minus 2 equals y cubed. So y equals the cube root of x minus 2. This is the inverse. First off, is it 1-to-1? Here's the first one. Here's g of x. It crosses at 0, so 2. So it looks like this. It passes the horizontal line test. So it is 1-to-1. Its graph is the cube root function. Its graph is the cube root function. Because instead of crossing at 2 here, it crosses at 2 here. So it is 1-to-1. Okay, that does it for that section. Pretty easy.